Hello friends, this video on Binomial Theorem Part 1 is brought to you by examfear.com. No more fear from exams. Let's understand why do we need binomial theorem. Let's suppose we have a problem where we have to expand a plus b to the power n, where n can be any values. Let's try with b is equal to 2. So if we are asked to expand a plus b whole square, if you want to expand a plus b square, what we will do, we'll say a plus b into a plus b. And this is equal to a into a is a square. This a into b is ab. Now this b into a is ba. And the left is b into b is b square. So what we got is a square plus ab plus ba plus b square. We can also say a square plus 2ab plus b square. This was quite simple. Now if we are asked to say find out a plus b whole cube, so what we will do? We will do a plus b into a plus b into a plus b. So first we will multiply these two. So what we will get is a plus b into this. We have expanded now, so we can use this a square plus 2ab plus b square. Now we'll multiply a with a square, we get a cube. Now get a with the second term, that is 2ab, that is 2a square b, plus a with b square, you get ab square, plus now with b with a square, so what will get ba square, so I'll write here ba square is a square b, plus b with 2ab, what you get is 2ab square, I'll write here, plus b with b square, you get b cube. So what you get, you add this. The reason why I've written like this is to make things clear. A square b is here. So what if you add this, what you get is a cube plus 3a square b plus 3ab square plus b cube. So if you see that when we solved a plus b square, it was a little simple. This was of medium difficulty. If we continue this, if we want to solve a plus b to the power 4, this will be more complex. Here will be, we have to first find a plus b whole cube, and then we have to multiply a plus b with this. So if you do like this, what you get is a plus b into a plus b whole cube, which we already found. We'll use this here, a cube plus 3a square b plus 3ab square plus b cube. So if you solve this, you will get, we'll solve this, a into a cube is a4, a into a square b is 3a cube b, this becomes 3a square b square, and this becomes ab cube, plus this becomes a cube b, this becomes 3a square b square, this becomes 3ab cube, and this becomes b4. So what you get is a4 plus 4a cube b plus 6a square b square plus 4ab cube plus b4. So if you see, it's getting difficult. The moment you increase the power, it's getting difficult. So if we are supposed to find a plus b to the power, let's suppose 30, it will take days to solve, because we have to say a plus b into a plus b 30 times, and then we have to solve it. It will become very difficult to solve such kind of questions. But in a lot of places, in scientific applications and other things, we need to find a plus b to the power 50 or 60. That means we need to find expressions to the high power. So what we should do? Here comes binomial theorem to rescue us. So here we have binomial theorem to rescue. But please note, this binomial theorem holds true only for n positive. That means if I say a plus b to the power 100 or 90, so let's suppose a plus b to the 100, it is true. We can find the values. But if I say a plus b to the power minus 100, we can't find the values. Please note, this binomial theorem is only for positive and only. So let's see what binomial theorem says. According to binomial theorem, if we have a plus b to the power n, any formula, we can expand this in this form nc naught a to the power n, nc1 a to the power n minus v into b, nc2 a to the power n minus 2 b square. We keep doing that till ncn b to the power n. So you notice there is a pattern here. The pattern is start with nc0. If you see, this is nc0, this is nc1, this is nc2, this is nc3, nc4. It goes till ncn. That is the coefficient. And if you see the actual expression, it starts with a to the power n, and this is b to the power 0 actually. Then the power of a decrease and b increase. For example, here a was n, it becomes n minus 1, that is minus 1. And here b was 0, it became 1. The next term, it will become again one more minus, so this terms become n minus 2, and this guy becomes 1 plus 1, 2. Similarly, it will keep decreasing. The coefficient of a will keep decreasing, and the coefficient of b will increase. That's how the formula is. Once again, if you see nc naught, it goes from nc naught to ncn. That is nc naught, nc1, nc2, nc3, ncn minus 1, ncn. And for the coefficient of a and b, first the coefficient of a, in the first case it is n and b is 0. And gradually we keep decreasing the coefficient of a and we keep increasing the coefficient of b by 1. So we can write the same formula in this form. A plus b to the power n is equal to summation. This symbol is used for summation, where I am saying k is equal to 0 and k goes to n. So if you see here, if you see k is equal to 0, it becomes nc naught a to the power n, because k is 0, and b to the power 0. So this is nothing but the first term. If you put k is equal to 1, this becomes nc1 a to the power n minus 1 b to the power 1. This is nothing but the second term. If you see, second term is equal to nc1 a to the power n minus 1 b to the power 1. Similarly, if you want to find the third term, k is equal to 2, that is nc2 a to the power n minus 2 b to the power 2. If you see, this is equal to the second term. If you want to find the nth term, this becomes ncn, k is equal to n, and this becomes a to the power n minus n is equal to 0. So this term a to the power 0 is equal to 1 is gone, and b to the power k becomes b to the power n. And that's what the last term is. Last term is ncn b to the power n. So if you see, we can also write a to the power a plus b to the power n in this form, where we say summation of nck a to the power n minus k b to the power k, where k goes from 0 to n. Let's take one example. If we say 2 plus x to the power 4. Let's suppose we want to find the value of this. So here a is equal to 2 and this x is equal to b. So if you see the formula, this becomes n is equal to 4 and this is n. So we'll say 4c0, a is 2 to the power 4 and x to the power 0, plus 4c1 2 to the power 3, 4 minus 1 into x to the power 1, plus 4c2 2 to the power 2, because we are subtracting this and we are increasing the power of x, plus 4c3. Again we decrease the power of 2, that becomes 1, and we increase the power of x, plus 4c4 into 2 to the power 0, that's 1, and x to the power 4. So this is the formula. If you expand this, 2 plus x to the power 4, it becomes this. Here 2 is equal to a, this is equal to 2, b is equal to x, and n is equal to 4. So we have used the same formula. N is equal to 4, we say 4c0, and this becomes 8 to the power n to the power 4, x to the power 0, because this is b to the power 0. In the next case, we say 4c1, we decrease the power of 2 by 1, that is 2 to the power 3, and we increase the power of x by 1. In the third term, we decrease again the power of 2 by 1, and we increase the power of x by 1. So if we notice this will come 4c0 is 1 into 2 to the power 4 is 16, and x to the power 0 is 1, plus 4c1 is equal to 4 into 2 to the power 3 is 8 into x, plus 4C2 is equal to 4C2 is equal to 4 permutation by 2 permutation into 2 permutation, and that become 4 into 3 into 2 permutation. So we'll cancel this. So you cancel this, it becomes 6. So it becomes 6 into 2 to the power 2 is equal to 4 into x square. 4C3 is also is equal to 4 into 2 into x cube plus 4C4 is equal to 1 into x4. So this guy becomes 16 plus 32x plus 6 into 4 24 x square plus 8x cube plus x to the power 4. So this is the expansion of 2 plus x to the power 4 using binomial theorem. It's very simple. You just need to understand the pattern. There is a pattern here. It starts with NC0, it goes to NCN. Every time you increase the NC0, NC1, NC2, you increase that the lower part of C by 1, and as far as A and B coefficient are concerned, you decrease the coefficient of A by 1 and you increase the coefficient of B by 1 every time. So you get this formula. Also you can say A plus B to the power n is equal to NCK, A to the power n minus k, B to the power k, summation k is equal to 0 to n. We'll prove this in our video. We'll prove this in the next slides, how this formula has come. But before that, you should remember this. This is very crucial formula. You have to remember this. So please pay attention to this. A plus B to the power n is equal to n c k, A to the power n minus k, B to the power k, summation k is equal to 0 to n. Also, there are some points to be noted in this formula. Here are some points to be observed. The total number of terms in the expansion is index count plus 1. For example, when you say expansion of A plus B to the power 4, this should have 2 plus 1 is equal to 3 terms. In our example, when we say 2 plus x to the power 4, it should have 4 plus 1 is equal to 5 terms. We'll see this. We'll go back and see the slide. So you see we have 2 plus x to the power 4. It should have 4 plus 1, 5 terms. Let's count. 1, 2, 3, 4, 5. So there are 5 terms in x plus 2 to the power 4. So the number of terms in A plus B to the power n is n plus 1. So the general formula is in A plus B to the power n expansion, number of terms is equal to n plus 1. Please note, number of terms is 1 greater than the coefficient. Also, the power of first quantity as explained goes decreasing by 1, where the power of second quantity as b increases by 1. I've showed you that the power of a increase and the power of b decrease. So if you see here, the power of a is decreasing, a to the power n, a to the power n minus 1, n minus 2, and here it is 1 and 0. But the power of b increase from 0, 1, 2, it goes to n. Also, each term of the expansion, the sum of indices of a and b is same and is equal to index of a plus b. So if you see, so in this term, if you see, the sum of index is always same. N is equal to n plus 0 is n, n minus 1 plus 1 is n minus 2 plus 2 is n, 1 plus n minus 1 is n, 0 plus n is equal to n. Here also if you see the common formula we have got, n minus k plus k is equal to n. So the sum of power of a plus b is always equal to n. That is the power of this. Here also if you see, since we have taken 2, so we can't find, but had this in y, we could have seen that the power is same. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.